In example 14.2, I want to look closely at the zeros that we found in example 14.1. This explains that a zero of a function has to be one of three types. It is either going to be a rational zero, a irrational zero, or a complex zero. Now remember that the rational and irrational zeros are still considered to be real, whereas the complex zeros are going to have the imaginary component in them. So I also want you to take a close look at the irrational and the complex zeros as we go through each one of the examples from 14.1. So let's take a look at 14.1 part A. Here we had x equals 5 and x equals -4 as the zeros. Both of those would qualify as being rational zeros. We're not really looking at the multiplicity here, we're just looking at the actual value of the zero and whether or not it's classified as rational, irrational, or complex. So those would be rational. Let's take a look at part B. With part B, we were having three different answers that were unique. We had x equals -6, which classifies as being rational. But the 2i and the -2i, those are going to qualify as being complex. On part C, we had found that x was equal to 0 and x was equal to 1. Those are both examples of rational zeros. On example D, we found three different answers, -7, +2, and -2, all of which are rational. And part E, we had four answers on this one. Two of them are complex. That would be the -1 plus I square root of 3 and -1 minus I square root of 3. And then we also have two that are rational. Those would be the 0 and +2 answers. And we did one more example. This was part F. And in part F, we have the square root of 7 and the negative square root of 7. These would both qualify as being irrational. And x equals -3 is going to be classified as rational. So certainly the most popular type of zero that we encounter is rational. And those are the kind of numbers that we deal with on a regular basis. Those are going to be your integers as well as your fractions, proper and improper. The irrational we don't see quite as often, and the complex we don't see quite as often. But I want you to notice here we have two irrational answers. If I go back to part E, we had two complex answers, and there was one more that had complex answers, and that should have been part B, and we had two complex answers. So what I want you to take away from this is that anytime you have complex or irrational zeros, you will never have just one. You will always have two. They always show up as a pair. These are called conjugate pairs. And I'll go ahead and write that on the main slide. So it said, do you notice anything interesting about the irrational and complex zeros? They always appear as a conjugate pair. And there'll be more on that in theorem 14.1 where we talk about the conjugate zeros theorem.